Hi y'all. In this video we're going to take a look at finding the determinant of a 3x3 matrix by using a process known as expansion by minors. So you're going to need to pay close attention to the process that I'm using in order to see how the process is used to find the determinant. Alright, so the very first thing I'm going to note right here is that we're going to find the determinant of this 3x3 matrix right here. It's got 3 rows and 3 columns, and the straight lines around the matrix itself says find the determinant of that matrix. In order to find the determinant of that matrix, I have written below it an array of signs. That array of signs is going to tell us whether we're going to add or subtract the minor that we're working on. So the very first thing we're going to do in this process is we're going to either pick one of the rows or one of the columns to expand by. And it doesn't really matter. No matter which row or column you pick to expand by, you will get the same answer. So I think what I'm going to do is I'm going to start with row 1 as my example first. And I've duplicated this determinant 3 times at the bottom of the screen, which you don't have to do when you're calculating the determinant of a 3x3, but it's only because I need to draw on top of it, and I'm going to show you how to find the minor. Alright, so I am going to go ahead and expand using the very first column in this example. So when you expand on the first column, you have 3 minors to find. You have a minor that's associated with this first value, a minor that's associated with this second value, and a minor that's associated with this third value. So let's go ahead and see how we're going to use the array of signs and those minors to calculate this determinant. So the very first thing we do is we need to determine, we're going to start with the very top number right here, this 0, and we're going to need to determine whether we're going to add or subtract that minor associated with 0. And we look at this array of signs and we say, alright, here is a plus sign in the same position that my 0 is in my matrix. So that tells me we're going to add this minor. So I'm going to go ahead and put a plus sign, even though we don't need leading positives. We assume things are positives. I'm going to just leave it there just so that you know what I'm doing. Okay, so we have a plus sign. We're going to write our 0 down because we're going to expand using the minor associated with 0. I'm going to put it in parentheses because we're going to multiply it by the minor. The minor, let's take a look at the very bottom, the very first duplicate of this determinant, is found by crossing off the row and column that our number that we're currently on is in. So 0 is in the first column and the first row. As you can see, we're left with a 2x2 matrix. 3, negative 1, 2, 4. 3, negative 1, 2, 4. Okay, so that is the minor associated with 0. Now we're going to move down to this next value, which is positive 1. And we're going to locate the sign in the array of signs, and it is negative. So we're going to subtract this time. Minus, we're going to take that 1 and put it in parentheses because it's going to be multiplied by its minor. And to find the minor, 1 is located in column 1, row 2. So we're going to cross off column 1, row 2, and we are left with the minor 5124. 5124. Now we're going to continue this process, move down to our negative 2, right here. Locate its sign in the array of signs, which is a positive, so I'm going to add this time. And I'm going to multiply by the negative 2. And to find its minor, negative 2 is located in column 1, row 3. So I'm going to cross off column 1 and row 3, and we are left with the minor 513, negative 1. 5, 1, 3, negative 1. So we already know how to calculate the determinant of a 2 by 2, so all we have to do now is do our calculations. So we end up with 0 times, let's calculate, 3 times 4 is 12, minus 2 times negative 1 is a negative 2, minus 1 times 5 times 4 is 20, minus 2 times 1 is 2, and then plus a negative, it's really a negative 2 times, 5 times negative 1 is negative 5, minus 3 times 1 is 3. Alright, so we know that 0 times anything is 0, minus 20 minus 2 is 18, minus 2 times negative 5 minus 3 is a negative 8, and we continue our calculations as negative 18 plus 16, and we get a negative 2 for this determinant. Okay, so now I'm going to go ahead and rewrite this entire screen again with the same matrix, and we are going to calculate using a different column or row, and maybe this time we'll use the middle row, row 2. So let me go ahead and erase this so that we can do our calculation again. Alright, so we're going to use 0, 5, 1, 1, 3, negative 1, negative 2, 2, and 4. And if you can remember, we got the result of negative 2. We should get the same result again. So I'm going to build my array of signs, and you can see that they just alternate across rows and columns. And this time I'm going to expand. Let's expand by our middle row here. Okay, so if I draw this 3 times, it might help me locate the minor. Negative 1, negative 2, 2, 4, and then 0, 5, 1, 1, 3, negative 1, negative 2, 2, and 4. Alright, so we're going to go ahead and expand by this middle row, and hopefully we'll get the same result, negative 2. So if we notice, this 1 right here is in this position, so we're going to use a negative this time. Negative 1 times. Let's go ahead and find the minor that we're going to use. This 1 is located in row 1, or column 1, row 2, and we are left with the minor 5, 1, 2, 4. Alright, number 3 is in column 2, row 2, and it has this sign, so we're going to add this time. 3, and it is in column 2, row 2, so we are left with the minor 0, 1, negative 2, 4, and now we have a negative 1 here, and we have a subtract in its position, negative 1, and its minor is, let's see, it is in row 2, column 3, so we are left with the minor 0, 5, negative 2, and 2. So let's go ahead and calculate our 2 by 2 determinants. So we have 20 minus 2 plus 3 times 0 minus a negative 2 is a plus 2. And this is going to turn out to be a positive 1. And we have 0 minus a negative 10, so it's a plus 10. So we have a negative 18 plus 6 plus 10, which is negative 18 plus 16. Again, we get a negative 2. So our result, again, is a negative 2. And you can do the same process using any column or any row, and the result should be the same. Occasionally, you will get a 0 as your answer. You can also get positive numbers as an answer. It just so happened that in this case, when we expanded by minors for this particular 3 by 3, that we got -2 as the determinant of this matrix.